I am going to use these 4 problems to review geometric series. So starting with the first problem, I have 2 plus 2 fifths plus 2 over 25 plus 2 over 125. What I'm trying to do is I would like to find the common ratio and then write the geometric series and then determine the sum. So this one I would like to do a rewrite first, so that is equals to the 2 instead of 2. Do you see that this is a 5, a 25 and then a 125? So this is like 5 to the first power. The 25 is 5 to the second power. The 125 is 5 to the third power. So I will just do a 2 divided by 5 to the 0 plus 2 divided by 5 to the first plus 2 divided by 5 to the second plus 2 divided by 5 to the third, things like that. And then I will catch the pattern. So this one is the summation. N goes from 0 to infinity, and then the A, I would like that to be a 2 because the 2 is not changing. And then the rest, I will just do a 1/5 and then raise to the nth power. So this one when n is equals to 0, when n is equals to 1, when n is equals to 2, when n is equals to 3, so on and so forth. So when n is equals to 0, so 1/5 to the 0 power is 1, you have a 2. When n is equals to 1, you have the first power. When n is equals to 2, you have the second power, so on and so forth. So this one, what is not changing? A is equals to 2, 2 is not changing, and then the common ratio is 1 over 5. And then since the absolute value of the common ratio is less than 1, then we say that the sum is finite. What do I mean by finite? Finite means the sum is equals to a real number. Then, alright, then what is the sum? The sum is, you have A divided by 1 minus the common ratio, which is 2, divided by 1 minus 1/5, so you have 2 divided by 4 over 5, and then flip the 5 to the top, and then you have 2 times 5 divided by 4, which gives the fraction. The sum is equals to 5 over 2. So what happened is, even though you are adding up infinitely many terms, so this is an infinite series because we keep on going, right? Even though you are adding up infinitely many terms, the sum is not super big. The sum is just 5 over 2. If you take another look, so you see that the numerator is always 2. The denominator is 5 raised to a power. So when n is very large, you have 5 raised to a very large power. So let's say 5 raised to 1000 power, that is very large, right? And then 2 divided by such large value is equals to 0. So the concept is, even though you are adding up infinitely many numbers, but once n becomes very big, 2 divided by a large denominator is just a 0. Therefore, this sum, 5 over 2, is really determined by the first few terms. Because when the denominator is so large, 2 divided by such a large number is 0. So basically, if you keep writing it as you look all the way to the right-hand side, those fractions are just a bunch of 0. So you are adding up a bunch of 0, that is not going to make the sum very, very large. Sometimes the problem asks you to find the sum. Sometimes they ask you to find the sum of the first few terms. The first few terms means you are not adding up all the way to the end. So let's just do a quick example. So let's say the sum of the first, let's do a 10. So the first 10 terms. And then what is the formula? The formula is that I would just say S, and then the subscript is 10 terms. That is equals to A, and then multiply. So this is a multiplication. I'm going to draw a dot for multiplication, and then 1 minus the common ratio raised to the nth power divided by 1 minus the common ratio. So that will be 2 multiply. The denominator is 1 minus 5 over 2, and then this is a 1 minus 5 over 2, but you raise that to the 10th power. So equals to whatever that equals to, that is the sum of the first 10 terms. So that means we are going from n equals to 0 all the way to n equals to 9, the sum of the first 10 terms. Okay, so let's move on to the next problem. The next problem in orange. So I'm going to copy this. So I'm going to do a copy and then do a paste, and then is there any way to rewrite that? Yep, you can do a little bit of rewrite. So the I can see that the 7 over 5, 7 over 5, 7 over 5, and then this is like the first power, the second power, and the third power. What about the 1? That's why I recommend you to do a rewrite. So the 1, I will just do a 7 over 5 raised to the 0 power, which is equals to 1, and then 7 over 5 raised to the first power, 7 over 5 raised to the second power, and then 7 over 5 raised to the third power, and then so on and so forth. So this one is n equals to 0, n equals to 1, n equals to 2, and n equals to 3. And then what about the geometric series? The geometric series is a summation. This is called a sigma. N goes from 0 to infinity because we are keep adding terms. And then the 7 and the 5, they are both changing, so I will just put a 1 outside. So 1 times anything is just that numbers. And then 7 over 5 raised to the nth power. Let's check. When n is equals to 0, yup, 0, I got a 1. When n is equals to 1, I got a 7 over 5 to the first power, which is right there. When n is equals to 2, when n is equals to 3, so on and so forth. So the common ratio is r, which is equals to 7 over 5. Compared to the previous problem, the absolute value of 7 over 5, this is not less than 1. So that means the sum is just an infinity. The sum is just an infinity. So that this one, take a look. 7 over 5 raised to the third power. 7 raised to the third power is greater than 5 raised to the third power, right? So if you change the 3 to a 30 or 300, we agree that we will get a very large denominator. The denominator is so much bigger than I should say the numerator. The 7 to the 30th power or 300 power is so much bigger than the denominator, which is 5 raised to the 30th or the 300th power. So this one, when you take that, the numerator divided by the denominator, the quotient is not equals to 0. So therefore, as n goes up, this value becomes very, very large. So 30, 300, 3000, this value is so large, and then you are adding them. That means you are adding up many, many large value. As a result, the sum is equals to infinity. I know you would like to ask me to do a what if. So hey, what if we have this summation 1 times 5 over 7 raised to the nth power, but this changes the whole game. So this one, r is equals to 5 over 7, and the absolute value of that is less than 1. So that means the sum is finite. The sum is finite means the sum is equals to a divided by 1 minus the common ratio. So 1 minus 5 over 7, which is 2 over 7, right? Oh no, sorry, not 2 over, which is 5 over 7. So you have 7 minus 5 is 2, so you have a 7 over a 2. 7, so 7 minus 5 is 2, and then you do the reciprocal. You flip the 7 to the top, and the sum is 7 over 2. If the common ratio is 5 over 7. Alright, so moving on, the next problem, we have this green problem, right? Okay, so I'm going to copy this, and then paste that down below, right here. And then can we do some rewrite? So this one, there is nothing to rewrite. We can pretty much see everything. But if you really want to do so, you can do that. So this is a 3. You can do a 1.1 raised to the 0 minus 3, 1.1 raised to the first, plus 3, 1.1 raised to the second, minus 3, 1.1 raised to the third, and then we keep on going, of course. So n equals to 0, n equals to 1, n equals to 2, 2, and then n equals to 3, and then we keep on going. So this one, the common ratio, if you want me to do a common ratio, yeah, I can do that. So what if you want to like do it like this? So the common ratio will be the next term divided by the previous term. For the last problem, that will be the 7 over 5 divided by 1. And then you take, which is equal to the second power divided by the first power, which is equal to the third power divided by the second power. So every time you do that, you get the same common ratio. The reason I would like to demonstrate this is because do you see the sign? Plus minus, the sign alternates. So the next term is negative 3, 1.1. Yes, you take the sign with you, divided by the previous term. So you have negative 1.1, right? And then you take the next term, n equals to 2. 3 times 1.1 squared divided by the previous term. You carry the sign with you, 1.1 to the first power. So that gives you a negative 1.1, which is always negative 1.1. Otherwise, this is not a geometric series. And then we take the fourth term, minus 3, 1.1 to the third power, divided by the previous term, positive 3, 1.1 to the second power. So this one you have a negative 1.1. So therefore, the common ratio is negative 1.1, absolute value of that 1.1, that is not less than 1. What happened to this? When the absolute value of common ratio is not less than 1, then we say the sum is infinite, is just a positive infinity. So this is called an infinite sum. And then how about the geometric series? The geometric series would be, so you have a summation. N goes from 0 to infinity. The 3 is not changing at all, so we'll just do a 3 and then negative 1.1 raised to the nth power. And then let's do a what if. Hey, what if you change the 1.1 to a 0.1? So what if you change the 1.1 to 0.1? What happened? Then you have 3 minus 3 times 0.1 to the first, plus 3 times 0.1 to the second, plus 3 times 0.1 to the third, and then what is the common ratio? The sign, minus. And then what is the common ratio? The common ratio this time will be the absolute value of r is equals to 0.1, which is 0.1, that is less than 1. So that means the sum is finite. Finite means the sum is equals to a real number. And then what is the sum? The sum is equals to a divided by 1 minus the common ratio. What is not changing? The 3. The 3 is not changing, and then divided by 1 minus negative 0.1. So negative 0.1, that is equals to 3 divided by 1.1, whatever that equals to, that is the sum. Okay, I remember that we have one more problem left. Yep, the one in purple. So I'm going to copy this, copy, and then bring that down. So bring it down, and then it's similar to the previous problem, except we have some square root, right? Okay, purple. So we have n equals to 0, n equals to 1, n equals to 2, n equals to 3, and then n equals to 4, right? So the common ratio is the next term divided by the previous term. Simple, right? And then we can keep going. The next term divided by the previous term. Well, this one, how come that is not the same as the last common ratio? Because you haven't rationalized yet. So multiply the top and bottom by root 2, and then there you go. So that one you have the 2 is cancelled, right? So negative root 2. And then you take the next term, which is nr is equals to, the next one is a negative 2 root 2 divided by the previous term, then you get a negative root 2. Okay, so therefore the common ratio is the absolute value of negative root 2, which is equals to root 2. Unfortunately, that is not less than 1. Not less than 1. What does that mean? That means the sum is infinite, is equals to infinity. So we call this an infinite sum. Although the sum is infinite, you cannot, like, is equals to infinity, you can still write the geometric series. So you can do absolute, sigma. N goes from 0 to infinity. So the, what is not changing? I would just say the 1 is not changing. And then the rest, negative root 2 raised to the n. So let's see. When n is equals to 0, you have a 1. Yup. When n is equals to 1, you have 1 times negative root 2. Yup. When n is equals to 2, the square root is gone. You have when n is equals to 2, the square root is gone, but this one is a positive, then you have a positive 2. Okay, so that looks right to me. Okay, can we do some what if? Yep, so we can do a what if. You have the common ratio is the square root of, I should add a negative right here, 0.5, that is less than 1. So the absolute value of that, absolute value of this, which is around positive 0.71, right? So if you approximate that 0.71, that is less than 1. So that means we can do the sum. So that one, the geometric series n from 0 to infinity, 1 times negative square root of 0.5 raised to the n, and then the sum is equals to the number that is not changing, which is a1 minus r, 1, and then 1 minus negative root 0.5. So the minus negatives becomes a plus, so whatever that equals to, that is the sum of the geometric series. Alright, so that is the end of this video. If you think my instruction is helpful, subscribe, like. Otherwise, I will meet you all in the next one. Signing out.